All right, we're going to wrap up lesson 15 with video 15E. So the idea of this part of the lesson is, what if we want to know before we actually do our study, how much data do I need to collect? So before engaging in a statistical study to investigate a population, care should be taken to collect a sample size that will meet our needs. So a few things that we want to consider. First thing we want to consider, what margin of error can you live with? If you end up with an interval that's too wide, it's going to be difficult to get any useful information out of that. So what margin of error can you live with? If we estimate the percentage of households in Cecil County where the owners have a gun, and we estimate it to be between 10% and 80%, that's sort of a useless interval. So you don't want your interval there to be too wide. What kind of margin of error are you okay with? Second thing to consider, what confidence level do we require? The predominant choices will be a 95 or a 99% confidence level. When making that decision, if there are severe consequences when creating an interval that might not capture the parameter we're estimating, then you want to be more confident. You want that interval to be a little bit wider. If not, you might be able to be okay with a 95% confidence interval. But predominantly, those are the two that we'll see most common. So you'll also want to ask yourself, what confidence level do I require? All right, so now let's figure out what sample size we might use. So the sample size formula is not a new formula. This comes directly from the margin of error part of your confidence interval formula. We're just going to take that margin of error formula, and the margin of error formula contained the sample size. It contained little n. We're going to do some algebra. Flash back to algebra class for just a second. And we're going to solve that equation for n. So the margin of error formula, you've seen this a lot of times now. What's this? And we're going to take this equation and we're going to solve it for n. So the first thing that we notice is the equation has a square root in it. We kind of like to get rid of that. So I'm going to go ahead and square both sides. So the margin of error gets squared. When we square this, if this had been 3a, you'd be squaring the 3, you'd be squaring the a. We're going to square both of these. So the z gets squared. And when you take the square of a square root, you're left with what's inside the square root. So all of this becomes p hat 1 minus p hat over n. So we squared both sides. Okay, the next thing that you'll notice is that n here is down in the denominator. And we'd really like to solve for n. So we could multiply both sides by n. When I multiply both sides by n over here, this is n times the margin of error, which is squared. Z squared, I still have my p hat, 1 minus p hat. When you multiply by n over here, those n's are going to cancel out, and you now have essentially 1 in the denominator there. And then finally, we're solving for n. The margin of error squared sort of in the way, so if we divide both sides by that, we'll have our formula for sample size. And so this is the formula that we'll use before we even collect data, if we'd like to figure out what size sample we would like. So we're going to go through this in this lesson. But this is the formula that we'll use. So not a new formula, derived right from the margin of error formula there. All right, before we use it, let's comment on a couple other things. The values for z and the margin of error come from the requirements that we had in 1 and 2 above. What margin of error did we require? What confidence level did we require? But what about the value of p hat? Where does that come from? Remember, you haven't collected data yet, right? P hat is the sample proportion. Well, you don't have a sample yet, so where does that p hat value come from? There's a couple of places we might get that. If you have an educated guess for p hat, maybe you've read a journal article or saw something in the newspaper, or you have a figure from last year, you might use that. An educated guess, though, is not a random guess. Don't just, pull a guess out of a hat here. If you have no idea what the sample proportion might be, then we're going to let the sample proportion be 0.50, be 50%. And the reason why we use 50%, this is the most conservative value. This will give us the biggest possible sample size that we might need. In that formula for sample size, part of it contained p hat times 1 minus p hat. If you plug in 0.5 here, you'll get 0.25. Plug in any other number for p hat, you'll never get a bigger value for this. So this will give us the biggest possible sample that we might need. If we have prior information, an educated guess, go ahead and use that. We'll end up with a smaller sample size. All right, let's do this. So let's look at an example where we might want to figure out our sample size. So at Cecil College, we'd like to estimate the proportion of students who would vote Democrat. A quick internet search reveals that Maryland is 56% Democrat, and no immediate information was available for the county, for Cecil County. We feel a 4% margin of error will work for our purposes, and we're happy with being 95% confident. Okay, so in A, determine the sample size that we would need if we are willing to assume that 56% Democrat is a good starting point for Cecil County. We don't know the percentage right now when we go to do this of Cecil County residents that would vote Democrat. So if we're okay with using this 56% as our educated guess, since that's for the entire state of Maryland, let's figure out the sample size we would need. So here, we're going to go ahead and use this as our best guess here. And some other things that were given above this. We said we're okay with a margin of error of 4%, convert that to a decimal, 0.04. And we also said that we wanted to be 95% confident. So if you want to be 95% confident, that's when we use a z-score of 1.96. And I think that's everything we need. So let's write down our formula for sample size. Same way we did earlier. So here it is. And now it's just a matter of plugging these values in. So our z-score was 1.96. That's going to get squared. We're going to use this educated guess from the state of Maryland of 0.56. And then we'll take 1 minus 0.56 and divide by a margin of error of 0.04. That gets squared. Make sure you've converted that to a decimal. If you put a 4 down there, you'll typically get very strange answers for your sample size. So plug this in your calculator, and if you do, we get that n is about 591.6. No matter what this decimal is, ordinarily you would round this number up, but even if this had been 591.1, sort of the rule here is that you'll always round the sample size up. We'd rather have one extra in our sample than not enough. We want to maintain that margin of error. So regardless of what this is, we'll round up and say that we need to sample 592 residents. If we sampled 592 residents, we'd be able to construct a 95% confidence interval that would have a margin of error of approximately 4% there. Okay, so that's part A. In part A, we had a best guess for the value of p hat. Let's go to B. All right, what happens if we want to determine the sample size, but we're not willing to assume that 56% is a good starting point for Cecil? Maybe you think, hey, in Cecil County, I don't think that's quite so high. I'm not sure that's a best guess there. So let's redo this. I didn't need to erase all of this, but I have. Okay, so if we're not willing to use this, so now we have no starting point. When you have no starting point, we'll use p hat equal to 50% or 0.50. This will give us the biggest possible sample size that we would need. Nothing else here really changes. Everything else stayed the same. So the only value in here that changed was p hat. We still want to be 95% confident. We still want the margin of error to be 4%. The only number that changed was p hat. And if you change p hat, we'll get 600.25. Again, we're going to round this up and say that we need to sample 601 people now. So you'll notice that in A, the sample size was 592. We didn't have a prior estimate. We got a slightly higher sample size here. All right, I think we've got one more example to cover. Maybe two. Nope, one more. So new example. In Cecil County, we'd like to estimate the proportion of homeowners that are currently behind in their payments. County officials would like to be within 3 percentage points with a 99% confidence interval with their estimation. So we're going to do parts A and B here with this one. How large of a sample size should we take? We learned from a Zillow report that 21.5% of Americans are late on their payments. So this is a proportion problem. We're interested in the percentage of Cecil County residents that are behind on their payments. We're interested in figuring out, before we've even collected the data, how many people should we collect data from, so how big should our sample size be? And so we're going to end up using our formula for sample size again. Before I plug in the values into that, I'll summarize what we know. This time we want to be 99% confident. So because you want to be 99% confident, the z-score that you'll use is the 2.576. So we'll have that. We learned from Zillow that 21.5% of Americans are late on their payments. We're going to assume for now that that percentage will work for Cecil County as well, so we're going to use that as our best guess for p hat. So we'll say p hat as a decimal is 0.215. And above this, it had said that Cecil County officials would like us to be, our estimate to be within 3 percentage points. So there they give you the margin of error to within 3 percentage points, 3% as a decimal, 0.03. And now we're going to plug these values in and determine our sample size. So 2.576, the z-score gets squared. We're guessing that p hat is 0.215. And the margin of error is 3% or 0.03, and the margin of error gets squared. Plug that in your calculator. We get 1,244.4. We will round that up. And so we think we should sample 1,245 households here in Cecil County. Fairly big sample size. All right, part B. What if officials want to reduce the margin of error? They weren't happy with the 3% margin of error. They want a really precise interval. They want to reduce the margin of error to only 1%. We're still going to use that Zillow value of 21.5%, but we're going to reduce the margin of error. You should write all of this down, but I'm going to cheat a little bit. Still want to be 99% confident. Our p-hat value hasn't changed. What does change is the margin of error to only 1%. Let's see how this affects the sample size. So the denominator here is what changes. Right there. And when we change that, plug that in your calculator. This time we find out we would have to sample 4,347.6, which will round up. We need to sample 4,348 households. I thought the sample size for A was kind of large. Imagine that you're asked to do this. Cecil County government hires you to find this out, and you have to make a decision here. Sampling 1,200 homes was going to take you long enough. Now you have to sample 4,348 homes. You're going to have to ask yourself, is the cost and the time in collecting that additional information, is it worth what you're going to gain? You're going to get a confidence interval here that's a bit narrower. It's going to only have a margin of error of 1% rather than 3%. You need almost 4 times the number of households here in your sample. So is that worth what you're going to gain from that? I guess it would be probably not, but it sort of depends on the consequences of what they're using that for. Okay, I think this does it for lesson 15. You learned about confidence intervals for proportions, and then finally, what if before we construct the confidence interval, you want to figure out prior to the problem what size sample would be needed. So that's it. We'll pick up with lesson 16. Thanks.